As we have discussed in the last section that in the real situation, if the resistive force exists in our system, the energy of the oscillation will decrease in time. So, if we want to keep the oscillation from this decreasing, it is possible to compensate the loss of energy in a damped system by applying a periodic external force. It means that we may apply the external force in terms of the periodic function like this. If we apply the force F as a function of time t, which equal to the F0, which is the magnitude of the applied force, sine omega t. Okay. So, the equation of motion can be written as the net force F is equal to the resolving force from the spring minus the resistive force from the medium and plus the external force. Okay, so we can put this equal to the mass times the acceleration from the second law. Again, to solve this equation is quite complicated, and we will not go into detail of solving this differential equation here. However, we can explain the situation qualitatively. The external force here, this term will give the energy to the system, and the resulting force is a conservative force, so the energy will not change from this term. But as we have discussed, the energy lost from the system by the resistive force. So this applied force will give the energy to compensate the energy loss from the resistive force. And when the energy given by the external force is equal to the energy loss by the resistive force, the system will go to the equilibrium state. It means that in equilibrium, the energy given by the external force must be equal to the energy loss by the resistive force, and the system will oscillate with a constant amplitude because the external force compensates the loss from the resistive force. It can be shown that the amplitude of the oscillation in the equilibrium oscillation is given by this expression, A is equal to F0 over M over the square root of omega square minus the natural angular frequency square omega 0 square plus B omega over M square. Okay. Here again we use this omega 0 as the natural frequency. From this expression, you can see that when omega is equal to the omega 0, the amplitude of the oscillation will have the maximum value, because when if you have omega is equal to omega 0, this term is vanished, and you will get the maximum value of A. If we draw the graph between the angular frequency of the applied force and the amplitude, we will have something like this. That is, when the angular frequency of the external force is equal to the omega 0, we will get the largest amplitude. We will get the largest amplitude A. Right? This is the peak of the amplitude as a function of omega. The peak of the curve also depends on B. Right? If we look at the expression of A again, you can see that if we have large B, A will be small. If we have small b, A will be large. So, for the large value of B, we have the small amplitude. Okay, and when we reduce the value of B, we have the larger amplitude. In the ideal situation, that is, there is no resistive force or B equal to 0. You can see that if the frequency of the external force is equal to the natural frequency, you will get the infinite amplitude, because if you look at this expression, you can see that if B is 0 and if omega is equal to omega 0, you can see that this term is 0 and A is approaching infinity. But in the real situation, we know that we cannot have the system with B exactly equal to 0. We may have the system that very small value of B. So it means that you can have the very large amplitude of oscillation when you apply the external force to the system with the frequency omega equal to omega 0. We call this phenomena as a resonance of the oscillation. In terms of the energy, when we have the resonance, you can see that the oscillation has the largest amplitude, which means that it has the largest energy, right? Because the energy is proportional to the square of the amplitude. So for the large amplitude, the oscillation has large energy. It means that the energy from the external force can transfer based at the natural frequency. And the natural frequency depends on the property of the system. In the mass spring system, it depends on the spring constant and the mass of the object attached to the spring. So if you know the property, the physical property of the system, you can choose the frequency of the applied force to transfer the energy to the system with the maximum rate. Okay, and this is also the reason that why we call this omega 0 as a natural frequency, because it gives you the value that you can put the energy to the system with the maximum rate. This phenomena is very important in practice. When you study physics 2, or when you study the more advanced course in electromagnetic theory, you will see that some electronic circuit, like the radio circuit, is like a oscillatory system, or like an oscillator. It's like a mass spring system, and the signal, the radio signal, is like the external force. The radio signal will excite the circuit, the radio circuit, and it will excite the base at the frequency that you can determine by the property, some property of the circuit, like a resistor or the capacitance in the circuit. And that is how you mark the radio channel. If you want to go to this channel, you change the property of the radio circuit to match with the frequency of the external signal, and you will get the signal will transfer the energy at the maximum rate, and you can get the signal based at this frequency. Okay, and once you change the property of the circuit, you change the channel, because you change the property of the circuit, and the natural frequency of the circuit change. The phenomena is also important, like in this figure. It shows the collapse of the bridge. When the wind passes through the bridge, it will make the bridge oscillate, and if the frequency of the oscillation match with the natural frequency of the bridge, the energy transfer from the wind will be at the maximum rate to the and it transfers to the bit at the maximum rate. And if the strength of the bit is not, it cannot stand for that energy transfer, it can be collapsed like this. This is an example of the force oscillation in the practical situation.